Mars is a world of extremes: towering volcanoes, planet-wide dust storms, and endless seas of sand. For decades, engineers have designed increasingly advanced rovers to explore the red planet. But despite all our technological progress, Mars still presents a simple problem that has challenged every rover ever built: getting stuck. In fact, one of NASA's most famous rovers spent years trapped in soft Martian soil. The challenge is obvious. How do you move across a planet covered in loose sand and dust? Surprisingly, the answer may come from a tiny creature living thousands of kilometers away on Earth: a desert lizard known as the sandfish. Today, we'll explore the fascinating story behind Mars Rover Sandfish Technology, a revolutionary mobility system inspired by one of nature's most extraordinary survivors, and why this unusual design could transform the future of planetary exploration. Deep within the Sahara Desert lives a remarkable reptile: the sandfish, known scientifically as Cincus cincus. At first glance, it looks like an ordinary lizard, but scientists soon discovered something extraordinary. When threatened, the sandfish doesn't run across the sand. It dives directly into it. Within seconds, it disappears beneath the surface, almost as if it were swimming underwater. Researchers studying the animal found that it uses wave-like motions to propel itself through loose sand. Its body creates smooth, undulating movements that generate forward motion while minimizing resistance. In essence, the sandfish treats sand like a fluid. This ability allows it to move efficiently through one of the most challenging environments on Earth. For engineers working on planetary exploration, this raised an intriguing question: could robots move through sand the same way? To understand why Mars Rover Sandfish Technology is so important, we first need to understand the challenge. Mars is covered by a layer of fine dust and loose sediment known as regolith. This material behaves differently than solid ground. Under certain conditions, rover wheels can sink, traction can disappear, forward motion can become extremely difficult. NASA has experienced these problems firsthand. One of the most famous examples involved the rover Spirit. After years of successful exploration, Spirit became trapped in soft Martian soil. Engineers attempted numerous rescue strategies, but eventually, the rover remained permanently stuck. The lesson was clear: even the most advanced robotic explorers can be defeated by something as simple as sand. And that's why researchers began searching for entirely new approaches. Instead of improving wheels, what if they completely reimagined how a rover moves? Scientists from Germany's University of Würzburg and their collaborators began studying the movement of the sandfish in detail. Using high-speed cameras and advanced simulations, they analyzed how the animal interacts with granular materials. What they found was fascinating. The sandfish doesn't simply push against the sand. It continuously redistributes forces through coordinated wave-like motion. This reduces sinking and increases efficiency. Engineers realized these principles could be adapted into robotic systems. The result was the development of Mars Rover Sandfish Technology, a new type of rover mobility system designed specifically for loose, sandy environments. Unlike traditional wheels that rely primarily on rolling, this system introduces dynamic motion patterns that mimic biological movement. The rover doesn't just drive over sand. It interacts with the terrain in a fundamentally different way, almost like swimming through it. At the heart of Mars Rover Sandfish Technology are specially designed wheels. At first glance, they may appear similar to conventional rover wheels, but their motion is dramatically different. Traditional rover wheels rotate in a fixed circular pattern, while these new wheels generate complex movements that combine forward and lateral forces. As the rover moves, the wheels create sinusoidal interaction patterns with the sand. This changes how force is distributed beneath the vehicle. Instead of digging deeper into loose terrain, the rover can maintain traction more effectively. The resulting movement resembles the swimming motion of the real sandfish. Testing has shown that the system can significantly improve mobility in soft granular materials. Researchers observed reduced wheel slippage, better stability, improved traction, and greater efficiency in loose sand. These improvements could be critical for future missions exploring some of Mars's most challenging landscapes. Many of the most scientifically interesting locations on Mars are also some of the hardest to reach. Ancient river deltas, dune fields, sedimentary deposits, potential sites where evidence of past life may be preserved. Unfortunately, these environments often contain loose material that threatens rover mobility. Future missions may need to explore regions that current rover designs cannot safely access. This is where Mars Rover Sandfish Technology could become a game-changer. Improved mobility means access to new scientific targets, longer mission lifetimes, greater exploration range, and reduced risk of mission-ending entrapment. Every additional kilometer traveled on Mars can lead to new discoveries, and every new discovery helps scientists better understand the planet's history. The Sandfish rover represents a growing trend in engineering known as biomimicry. Instead of inventing solutions from scratch, scientists look to nature. After all, evolution has spent millions of years solving complex engineering problems. Examples are everywhere: gecko-inspired climbing robots, bird-inspired drones, fish-inspired underwater vehicles, and now, sandfish-inspired planetary explorers. Nature often discovers efficient solutions long before humans do. By studying these biological systems, engineers gain insights that can improve robotics, transportation, and even space exploration. The future rover exploring Mars may not look entirely like a machine. In some ways, it may behave more like a living organism. The story of Mars Rover Sandfish Technology reminds us that innovation often comes from unexpected places. A small desert lizard, a sea of sand, and a challenge millions of kilometers away on another planet. As humanity prepares for the next generation of Mars missions, mobility will remain one of the greatest obstacles to exploration. The ability to cross dunes, navigate loose soil, and reach untouched regions could determine what discoveries await us. Perhaps the key to unlocking Mars's secrets won't come from a massive rocket or a powerful computer. Perhaps it will come from understanding how a tiny creature learned to survive in the desert. Because sometimes, the future of space exploration begins with looking closely at life here on Earth.